Okay, Gurmahagath agus Fáilte. Just want to very quickly start by saying a couple of thank yous. And first up, I want to say, I know we have a captive audience here, but I want to say thank you for your time. Appreciate it. I know time is precious. And also just a quick shout out to the organisers / volunteers for letting us pitch and for organising this event. And then finally, I want to give a shout out to Jennifer Petoff for stealing our thunder yesterday, or no, sorry, on a positive note, for setting us up, so giving us a platform so we could talk about our journey on SRE at Cisco Galway. Okay, so over to introductions. My name, as Emma said, is Kevin Connaughton. I'm part of the SRE / operations team at Cisco Galway. I've been at Cisco for 8 years, and I started in Cisco Galway in a QA role. I guess in preparing for this talk, I have to admit that I was wondering, was I a bit of a charlatan when it came to SRE, because I wouldn't be from a strong programming background. But that said, I've done the hard yards when it comes to sysadmin type roles before I came to Cisco. I've been one of those guys that sat on the floor of a cold server room in vendor sites in the wee hours of the morning. You'd have a phone in one hand, laptop in the other hand. So that's sort of where my experience is. And I think I was speaking to Jennifer after the talk yesterday, we discussed about, is it necessary to have all software engineers in your SRE team? And it's not necessarily the case. It's good to have the diversity. And just to emphasize that, I was actually listening back to a talk by Stephen Thorne, who's also a Googler over in London, and he gave a talk recently and emphasized the same point. Then just one little bit of trivia about me, I guess. Last time I gave a speech to this many people was in a room very similar to this, and it was just down the road at the Great Southern Hotel, now the Merrick, and I was the best man for my brother. That was back in 1998, so quite a while ago. But even back then, maybe I was an early adopter because I used a PowerPoint slide deck at that time as well. One of the first, I think, in Galway anyway.
Okay, thanks. So I'll introduce myself. My name's Arron Forde, also part of the same SRE / operations team at Cisco Galway, working on the same cloud-based product. I've worked there for the past 7 years as a software developer, and recently taking a lead role in applying what we're going to discuss today to other teams within Cisco Galway. So what are we going to cover in today's talk? We're going to go through a quick insight into the project we applied this process to, so that you can all see how it can be applied to your own projects, along with the definition of site reliability engineering, its key elements and tenets. And then we're going to pull apart each of those key elements with an explanation, how we applied the element, and further possible improvements in that area. Let's call it our journey through SRE. The key elements being obviously the structure of the teams, meetings and iteration process, identifying and actioning toil, what are service level indicators, importance of metrics and monitoring them, and finally how to handle incidents effectively. Just before we continue as well, I'd also like to start with a couple of statements. We're presenting these learnings about adopting this process, but I'd like to acknowledge that it's very much a combined set of learnings with our team, Cisco Galway, some of whom are in the audience, and even the organising committee, I guess, of this conference. And also, you may hear us use the term operations team and SRE team quite loosely, as I guess we started off with the operations team as the term for what we do today, but it follows very closely, as you'll see, to the SRE model.
Okay, let's begin by giving an overview of our product, first of all, to set the context. And the aim here is really to demonstrate how we differ from other enterprises, and thereby giving you an appreciation of how we came to our own particular adoption of SRE. So as you can see, our product is an enterprise cloud calling solution. It's called WebEx Calling, and it's hosted predominantly in AWS. And as you can see, we have video-enabled endpoints, and they're out at our customer sites, and they're connected over the top to the cloud solution. So in terms of AWS, we have EC2 instances to run all our call processing engine and our edge components, among other components. We have a number of Cloud Foundry microservices, which we'll explain later, and we also have we run some AWS Lambda serverless code, and we use that mostly for alerting. Then we have a fully redundant AWS data center in production, which we switch between on a monthly cadence. We use AWS Route 53 to switch between the data centers, and we integrate to that using Bodo 3. We also update our routing records when we're switching between active and inactive for new releases. So carrying on from that, 4 years ago when we started this project, it was basically a clean slate. So, and not only was it a greenfield project, but it was also a transition from on-premise development to cloud for many of the development team. So we had a lot of learnings and challenges ahead. But I guess straight up we knew that the typical model for operations and support would not scale. So we looked at best practices at the time. And from there we adopted and tweaked some of the core tenets of SRE. And this is kind of a recap from yesterday, but some of the quotes from the SRE handbook might say that SRE is fundamentally doing the work that has been historically done by an operations systems administrator team, but using engineers with software experience. And maybe just to emphasize that SRE is what happens when you ask a software engineer to design an operational team. And it's often used for large distributed computer systems. I guess if there's one core belief by the SRE, it's that the most fundamental feature of any product is its reliability. So I guess Google compiled a set of principles to try and achieve that. And if you wanted to break it down, I mean, it was called out yesterday, the difference between SRE and DevOps, but in a nutshell, SRE is really more focused on the systems engineering role.
So, as Kevin mentioned, we adopted the SRE model. So what does this model look like in our organization, or in a organization, and what about the alternatives? So, Google have development team or teams and different SRE teams. They have clear handoff requirements for development teams to the SRE team, and on the flip side, consequences for development team enforced by the SRE team to maintain quality. Netflix, however, have a cross-functional team where they build and deploy in one, and this is called, they coin it the freedom of responsibility approach. I guess while the Netflix model is building the shared responsibility by putting people on similar teams, the Google model is building shared responsibility with tools and techniques, and guess what? It's the same high velocity, same high quality results from both. And obviously both of these companies are known for how they build and run their services. So I guess the point here, the key point is that not everybody's enterprise's go-to-market strategy fits these models. So let's take a look at what Cisco did to adopt SRE. So we have a clear SRE team and feature development teams with clear boundaries to maintain quality, just like Google. Working off Agile with 2-week sprints, 8 engineers approximately per team. However, the main difference is we introduced a rotation model of engineers into our SRE team. 6 to 8 weeks we found was the best. We felt it removed the fire it over the fence mentality, ensured there was greater responsibility for code changes, whilst helping to get a fresh set of eyes to identify toil items in the SRE team. And also, of course, it gives the folks developing features a good understanding, and they're also getting to think of deployment and supportability throughout their development. So this model ensured that everyone in the wider team knew how to support the service, and this also gave us a bigger rota for out-of-hours support. Initially, this rotation model worked well and continues, obviously, to work well. However, we've iterated just a little bit further on this by keeping an engineer or two in for longer periods of time in the SRE team. Helped maintain consistency, and I guess it's an anomaly that we're trying to work through to find a sweet spot for our SRE team. One of the points here is that the SRE team was sized dynamically, depending on the incoming issues. Our current model with 2-week sprints allowed us to adapt quickly and even reduce the size with maturity. Okay, continuing on with the process, I guess, that we followed. As I mentioned, our feature teams were following an agile process for structures, so the SRE team naturally followed some of these structures to fill in the gaps and keep abreast of incoming development changes. The forum for most of this was at end-of-sprint demos, where the SRE team enforced feature completeness and reliability, and also presented readouts on service health metrics, for example. As we were part of the larger team also delivering the same product, we attended the weekly team tech talks so we could learn together as a team, so we weren't siloed into our teams. Also, there was a daily operationals call. We deemed this necessary just to ensure that correct priorities being worked on a day-to-day basis, as things seem to change very frequently in the SRE team. And then, as with all services, we've had our horror stories, our outages. We have a clear, blameless post-mortem process that we call RCAs, and from these we codified gates to prevent issues like that happening again. We got beyond blame, I guess, as a team, and considered our outages as an opportunity to strengthen our pipeline. Now, of course, we have to have a ticket system. We're all still engineers, and we strive for some order, I guess, on chaos. And also, as we have to reprioritize quite frequently with the SRE team, an efficient system is a must. New issues checked daily to ensure they are valid, correctly prioritized, and also we implemented a once-a-week scrub of these issues to bring experts in to help further groom and prioritize. We settled on Jira as the tool of choice, mainly very flexible and mature, allowing us to put in effort at the beginning. We were able to create dashboards, filters, and then we were able to take a kind of a backseat approach for the day-to-day operations. By backseat, I mean that we have multiple integrations that we leveraged. By identifying toil early, we were able to generate a chatbot that was able to ping us and alert us on new Jiras. So then we were a more reactive rather than proactive team, freeing up the SRE engineers, I guess. It also gave us the ability, as I mentioned, to size the SRE team dynamically, and it was this main metric that we used at the Jira throughput to apply that.
Okay, so just going back to some of the core tenets of SRE, as called out yesterday, toil is one of those, and on this slide it kind of goes a little bit further. It says toil is the enemy. And there's the quote there, I think was called out yesterday from Vivek, that toil is the kind of work that is tied to running a production server that tends to be manual, repetitive, automatable, tactical, devoid of enduring value, and that scales linearly as the service grows. And we have another slide here which kind of like just breaks that down a little bit more. It shows you more or less the same words, but just like in a table format. Okay, so the objective here really is to reduce the toil. So I guess if you read the SRE handbook, it would be that site reliability engineers typically spend up to 50% of their time dealing with the daily care and feeding of software applications, and they spend the rest of their time writing code, just like any other software developer, but with a focus on automating away the toil. I guess basically you don't want to be stuck in that firefighting mode. You need to get that engineering time to improve how we work, and of course you need leadership buy-in to achieve this.
Okay, great. Now we know what toil is. Let's run through a real-world example that we have implemented. So our pipeline is probably the finest example we have of identifying toil and removing it successfully, automating away today's work. Initially, there was a large amount of manual effort deploying our code to production. We even needed a second engineer to observe and ensure any of the manual changes made on AWS didn't include any errors. We used Ansible and Jenkins to script our deployment flow, reducing most of the manual effort. We then took our Jenkins jobs, scheduled them to run, and automated away any manual deploy decisions we had, like checking system health and changelog monitoring, for example. Also, then we took this to another level again by completely syncing up all of our backup data centers that Kevin mentioned, getting us to a hands-off deployment pipeline that alerts the SRE team if an issue occurs. Again, moving us to a reactive rather than a proactive SRE team. And I guess another added benefit on top of time saving is the reduced opportunity for human error and risk. Now, 100% of our deployment time is automatic, and the frequency of our production deploys is up tenfold. I guess while our feature code was now in a lovely automatic pipeline, there was a lot of happy engineers for a while until we hit one more toil item. The Jenkins and Ansible scripts we used to deploy our software to our data center was versioned, but was not in a pipeline of its own. Therefore, there was a chance of a change to an Ansible group or a change in some deployment parameters, for example, and the first time them changes were run was on an actual automatic deploy to production. Not a great idea, so I guess the SRE team had to manually ensure that this didn't happen, but once we identified this manual step, we went about automating it away. Perfect example of toil. So now for our deployment code is in its own pipeline, has to go through its own integration test deployments before getting promoted to production deployment code. All in all, SRE team regained confidence in their tools to deploy the software. I guess we've one other toil item that we've identified and we're planning to work and address in the future, I guess, is our scale issues, I guess. At present, we have some static thresholds in place, so when we exceed those thresholds, the SRE team gets alerted and extra nodes are added by the SRE team to handle load. It's a manual effort at the moment, so we'd like to make that a little bit more dynamic and also giving us the ability to scale up or scale down then for cost saving. So that's a thing that's on our radar, I guess. Okay,
our next core principle or principles here is the SLI SLO, SLAs that were also mentioned yesterday. So just to recap, SLI, service level indicator. I guess you can have SLIs for various different metrics, such as availability, latency, or quality, just examples. And an actual example of one SLI for latency might be the proportion of home pages requests served successfully in less than 100 milliseconds. So then SLO, service level objective, is the goal for how much availability or latency or quality you want out of your system. Basically, what you are prepared to tolerate. And another example of that might be that you want 99% of those page requests in the past 28 days served in less than 100 milliseconds. And then SLA is more the traditional approach or agreement, where what happens if you're not meeting those objectives, i.e. you put a freeze on deployments until an SLO is achieved. And as shown, I think this diagram here gives a good indicator of that there. And then the difference, the error budget, is the difference between SLI, SLO. And there has to be a consequence, which has been called out before as well. If the error budget is used up, the team must then expend their time involved in testing or improving the testing suite, or maybe monitoring capabilities of the system. And just to call out also that it's good even just to have the conversation with the stakeholders regarding the SLOs and SLIs and get agreement across those stakeholders, being project managers, SRE team, developers, etc. And something that probably we need to improve on, it was called out yesterday, is maybe even to document those SLOs. And then finally on this point is that here we have actually developed service level indicators that give us metrics on service health, pipeline health, and SRE team throughput. Eventually these became live dashboards and even fronted by bots where we could query at any time from anywhere. This also gives us the ability to make automated pipeline decisions. And this, our next slide, is just a quick example maybe of an SLO that we use in our deployment pipeline. So here early in our project, we basically developed a full automated suite of end-to-end tests in Python. And now our automated deployment pipeline is gated on an SLO based on these tests. So for example, we might have 100% pass rate on our quick sanity tests, and a 98% pass rate is necessary on our detailed sanity.
Okay, so Mikey Dickerson is a former site reliability manager at Google, and he created this hierarchy of reliability. Excuse me, with the most important need at the base of the pyramid, monitoring. Monitoring is fundamental. The formal definition is collecting, processing, aggregating, and displaying real-time quantitative data about a system. Next is incident response or alerting. Something is broken, someone needs to fix it right now, or something may break or is about to break and someone should take a look soon. That's alerting in a nutshell. Monitoring and alerting together enables a system to tell us when it's broken or it's about to break. And when a system is not able to automatically fix itself, we want a human to investigate that alert, determine if there is a real problem, and determine the root cause. Another journey we took around observability is with our metrics and dashboards. Initially, I recall the SRE team having upwards of 15 bookmarks to dashboards that we would check multiple times a day, all monitoring system health and trying to identify issues early, I guess. We iterated on this toil item, I guess, to generate smarter dashboards with thresholds that alert engineers, again, moving to a reactive process rather than proactive. And I guess here's an example of one of these smarter dashboards implemented in Grafana. So I guess we can go through a very recent horror story that we had 2 or 3 weeks ago whilst migrating to a backup AWS data center. Our EC2 instances ran into issues, exceeded CPU thresholds, as you can see here, and paged our SRE team. I guess we applied good incident management practices here, swapped back to another well-behaved AWS data center, and investigated the issue without the extra pressure of an outage. A medical analogy that often gets used here to describe this behavior is getting a patient from ICU to regular ward care. Thankfully, these planned data center switches are to keep our redundancy sites and process well-oiled, and these are completed in maintenance windows, so there was no actual real customer outage here.
Okay, so back to our product. When transmitting voice and video, quality is the key. And much of our monitoring is based on media quality. And our goal, I guess, is as an ops team, we need to know if a customer is our users having media quality issues and what is causing those problems. So you need to measure the media experience of our users, prioritize measures to improve media quality, diagnose, identify media quality issues. Okay, so if we go back to our actual product, you can see here we've got raw stats that are being generated by 3 different sources. These are what we call tier 1 metrics. And say there's stats coming in from the phones, which are on customer sites, from the edge devices, and the call processing engine, which is in AWS itself. So we developed a Python-based Cloud Foundry microservice called the Media Quality Analyzer. It extracts these tier 1 raw stats from the ELK stack, enriches them, and pushes them back into Elasticsearch. It creates daily and hourly aggregations on a per customer level and on a per call path level. Then having all this data dimensioned correctly lets us create some really powerful dashboards in Kibana. And I guess here's a sample of one of those dashboards. So now in our daily ops call, we can view the overall quality and loss over all calls. We can see which media path is performing best and which is performing worst, which particular customer is better or worse in terms of call quality. So I guess we can proactively reach out to customer based on lost, and our baseline is complete customer base. And in terms of impact, we can quickly work on issues which are the most significant and which fixes improve the most cases for the most users. And this is scalable. We can work when this is thousands of users or millions of users, and it's repeatable and automatable. And I guess finally on this point, if, as an example, you take a tier 1 metric such as packet loss reported by a device, if we enhance that metric, we can build an SLO such as if more than 10% of our largest customers are experiencing greater than 0.5% packet loss, then we need to take action. So we do and we are alerted on such metrics. And as an example, even this year, on another DC flip, we started getting paged for this particular alert. And when we were able to investigate it, we determined that there was a problem with fiber interconnects into one of the AWS DCs. Just a final point here is that we do focus here on percentiles and not averages. Okay, so next up is incident response. So I guess just some of the mechanics. I know there was a talk on PagerDuty or on call this morning, but just for our own, the way we work here in Cisco Galway, from the start we had a PagerDuty pool which was made up of the engineers from both dev and ops. And as Aaron mentioned, the developers would rotate into the ops team. And I guess spending time in that ops team would help you prepare for being on call, and it would also align incentives between developers and operations. I guess we initially used a primary and secondary solution, but over time we moved to just a primary only with Follow the Sun. The change suited our setup as the number of incidents declined as the product matured, and I guess you were on call less often. But I guess we can see the merit in having a primary and secondary, both for practical reasons and to reduce that stress burden. So, as is shown here on the slide, our incident response has matured over time. I suppose in the beginning we relied a lot on the hero mentality where a subject matter expert would parachute in, save the day. But now we move to a model of having well-documented processes with learning inputs to the process. But I guess getting to that point of having good documentation has its own journey. And we realized that the organic growth of the content was getting out of hand, and critical ops content was hard to find. Because we had content littered in different wikis, repos, shared folders, etc. So we followed the SRE model and created runbooks, like was mentioned earlier this morning as well, and we placed them under source control. But I guess as documentation is always put on the long finger, and for it to be done well, it has to be done, it's a collective responsibility. One of our efforts to organize these runbooks was to do what we called war games. So basically, for us, these war games were just, we'd set up workshops which involved both the ops team and the devs teams. We split these into small groups, and then we'd assign a scenario to each group, and that group would take that away, discuss how best to triage the incident. They'd pull the logs from and work on them and use troubleshooting first principles. They check for existing docs, does any exist, and search the chat rooms for similar incidents, which should have recorded how the incidents were resolved. And then the outcome of that would be you'd write up a skeleton run book as a group, talk through the triage steps, present the findings to the other groups, and then refine and publish. I guess bottom line is we want a maximum return on valuable information versus the time spent creating it. And I guess here, this is just a sample template whereby we have, at the top, we want to make sure that if a guy gets called at 2 o'clock in the morning, he's got a context for the actual, what he's being paid for, because he might not be a subject matter expert in that area. And then set the customer expectations. And then, of course, troubleshooting steps. They need to be concise and the most important information at the top. And if possible, add links to dashboards and commands that need to be run, but you have to be very careful with those to make sure they're executed in advance and everything is okay. And of course, as was called out this morning, you're not alone basically on these things, so an escalation path, and we often put in links to previous incidents as well. And then Aaron called this out earlier, but we do use chat rooms as collaboration over email, much like any other company, and we have dedicated rooms with PagerDuty integrated for incidents. And we have developed the chatbot, as Aaron mentioned, which integrates with PagerDuty itself, and it'll pull a string from the associated page. Then it runs a fuzzy logic search of our runbooks. It'll find the matching runbook and post it, just like in the slide here. It basically rules engine, I guess, using if this, then that approach. Okay, so then sort of basically if there was a little thing we're working on right now on the future, it's the smarter paging. So we want to avoid those pages, a bit like was mentioned earlier as well, where that if it's not actual issue. So read through the actual logs of the page, classify those pages, and then when they're put in a particular bucket, we can run further actions on those. So the next time we hit this issue, it'll avoid someone being woken up.
Okay, let's recap on the key takeaways and learnings when trying to adopt SRE into your enterprise. I guess one size SRE does not fit all. Be open to modifying process that's in the books. Keep identifying toil. There's always room for improvement. Reliability is #1 throughout all iterations of code base and process. And patience through process changes. Give changes time to see if they pay off. I guess we're still on this journey and iterating also on this process. And I guess the final point is that this was our blueprint for SRE and DevOps for a single team in Cisco Galway that we've obviously now started to apply to other teams with great success. And wrapping up, we're going to recommend obviously the 3 O'Reilly books mentioned yesterday, and also like to reference Damon Edwards, who's an expert in improving how businesses operate. I think he wrote a chapter in the latest Seeking SRE book. I've also included some links to other SRE talks and a weekly newsletter. And any questions?